Okay, so we are back. Today is 2nd of December 2020. My name is Ferhan Mazher and we are with the 11th Cambridge class. Subject we are studying is physics. And the we are doing today the October-November 2019 2-1 paper. And we have decided to do section B. We are on question number 8 and we are on its C part. The question is explain what is observed on the ammeter when a student inserts a north pole of a bar magnet slowly into the right hand end of the solenoid. So here I have drawn, can you see this diagram now?
Yes, sir.
Okay, so he said that we have this is the solenoid and we have a bar magnet. Its north pole is towards the right side of the solenoid. And when this north will approach this solenoid, automatically what happens? The right end of the solenoid becomes north. It tries to oppose the motion of the bar magnet. So when the north is approaching the right side, to stop it, the right side will become north. Okay. So and this side will become south, and because of the magnetic flux, the magnetic flux of this bar magnet passing through this solenoid, it will be changing. The EMF will be induced, the current will be induced in this solenoid, and the ammeter here will show deflection. Okay. So this is the first part of that thing. This is the, let me show you the marking scheme. Ammeter shows our reading. Okay, that's the first part. So will you write the answer? You see, when the north pole will approach the right side of the solenoid, the magnetic lines passing through the solenoid, they will change. So the EMF will be induced in the solenoid and the galvanometer will show deflection. Kusam, you will write the answer?
Okay, sir. Wait.
Okay. Okay. 3-mark question. Here are this is a 3-mark question. So the one thing you should mention is when that bar magnet will approach the right side of the
Sir, मैंने लिख
solenoid.
ली है.
So kindly read your answer.
Right hand end when N pole will be slowly approaching will become N pole, which will try to oppose the motion as North pole is approaching in the solenoid. There is a change in magnetic flux inside solenoid, which will induce EMF and current. Hence, ammeter will show deflection.
Okay. The first lines which you wrote, okay, the first
Yeah.
lines which you wrote, where you wrote that the right end of the solenoid will become north, they are not necessary. I was just telling you for your understanding, okay? The last lines
Okay,
are
sir.
the, okay? The first lines where you wrote that the right side of the solenoid will become north, that is true, but that I was just telling you for explaining the whole idea. And the basic answer should be that when the north pole of the bar magnet approaches the right side of the solenoid. You don't have to write these sentences. I'm just trying to explain. So what happens, because the magnetic flux passing through the solenoid will change, this will induce EMF in the solenoid and the galvanometer will show deflection. Anybody else will like to read? Chantal, have you written your answer?
सर नेक्स्ट बात करें.
There is nobody. Just you two are here.
उसका शायद नेट इशू है.
अच्छा.
Holds the bar magnet stationary in the solenoid.
Okay. So when the bar magnet is stationary, the magnetic flux passing through the coil become constant. So no EMF is induced and the galvanometer shows no deflection. You see, when the bar magnet becomes stationary, the magnetic flux passing through the coil becomes constant. And when the magnetic flux becomes constant, the EMF induced, there is no EMF induced, so the galvanometer will show zero deflection. Kindly write that answer.
सर लिख लिया है. रीड करो.
So kindly read your answer.
When bar magnet is stationary in solenoid, there is no change in magnetic flux, hence no EMF and current induced, so no deflection is shown on ammeter.
Okay. So in the marking scheme, he says no deflection and no magnetic field lines cut or constant field. Okay. So your answer is good.
Next पढ़ो.
Wait for others. You see, he says withdraws the north pole of the magnet quickly from the right hand end of the solenoid. Now they have changed the situation. Let me show you that. Now what they are doing, they are going to take this bar magnet away. Okay. Can you see this paint file?
No. सर आप आगे कराएं, हमें समझ आ रही है.
Yes,
Oh
sir.
my God. Can you see this file?
No.
Meerab, you can also not see this file?
सर ये जो आपने ड्राइंग है जो.
हाँ जी.
जी सर आ रही है नजर. वो जो नॉर्थ और साउथ पोल में है.
हाँ जी. तो कुरसम.
हाँ जी सर.
सर मुझे भी आ रही है.
अच्छा. So now he is saying that the north end is towards the right side of the solenoid and he is taking this away. So when he is taking this away, to stop this motion, this end will become south and this end will become north. Okay. You see, when you take this bar magnet away, the magnetic flux which is passing through this solenoid, that will change. So the EMF or the current will be induced in this solenoid. But this time, the current will be in the opposite direction, the direction it has in the first part. The direction of the current will be opposite to that direction which was in the first part when the north pole was approaching the right side of the solenoid. So the galvanometer will show deflection but in the opposite direction. And another very important word he used is he withdraw the bar magnet quickly When you will move the bar magnet quickly, the amount of the EMF induced will be larger. So the galvanometer will show a larger deflection. You see, two things are happening. When the north pole is withdrawn from the right end of the solenoid, the current produced will be opposite to that which was produced in the first part. So the galvanometer will show deflection in the opposite direction. He said the galvanometer, so the bar magnet is moving quickly. So that's why the EMF induced will be larger. Due to this, the galvanometer will also show larger deflection this time. The deflection will be in the opposite direction and the deflection will be larger. The reason is because you are moving the bar magnet quickly. That's why a larger EMF induced. And because you are withdrawing the north pole from the right side, so that's why the EMF will have opposite direction. That's why the deflection on the galvanometer will be in the opposite direction.
Sir, read करूँ answer?
You have written your answer?
Yes.
Okay. So I am also showing the marking scheme if if you are able to see it. G, please read your answer. It's a 3 mark. It's a 3 marks part.
When N pole is withdrawn, there will be change in magnetic flux in the solenoid. EMF and current is induced, but the direction of current will be opposite which was produced in first part when it was inserted. Quickly withdrawn, more EMF will be induced, hence ammeter will show greater deflection and in opposite direction.
Yes, that's the answer. It's a 3 marks. You get the 3 marks. See, on the marking scheme, he says 1 mark for the larger deflection, 1 mark is for saying the opposite deflection, and 1 mark is the field lines cut in opposite sense or opposite change in the magnetic field or field lines cut faster.
9th question.
Okay. Meera, do you have written your answer?
सर लिख लिए पर the different है questions.
So please read your answer, then we will be able to check it.
क्वेश्चन ही गुम हो गया.
सर मीरब का थोड़ा सा नेट इशू है.
Everybody has that issue. I also have some that.
Yes, sir.
बीबी वालों का तो वैसे ही बहुत गंदा होता है.
Yes, sir. इसका मैम सर व्हाट्सएप पे भी सही से मैसेज नहीं आ रहा था. सर क्वेश्चन नंबर 9 करते हैं.
अच्छा चलें. Kursam, we can do one thing. Once it is done, then you can take the snaps of your work. Okay?
Okay,
and share with us all. Okay?
Okay.
Okay. Here, please read the question.
Figure 9.1 shows the structure of water cooler that is used to supply cold water to the workers in hot office. A part. The reservoir of water in the plastic container is at room temperature. It does not mix with the cold water in the tank below. Explain why.
Okay. You see, because the hot water is the cold water is in the bottom and the hot water is above. The cold water has higher density and the hot water has less density. One thing. The other thing is that the hot water cannot mix with the cold water quickly. I mean, the reason can be that the heat is transferred in the liquid by the help of the convection currents. and by the help of the convection currents, the heat travels always in upward direction. So if the cold water is below the hot water, then they cannot mix very quickly. They will ultimately mix, but not very quickly, because with the help of the convection currents, heat always travels upward. Okay. So let us first check what is how many question numbers we have. 2 marks. This question is 2 marks. Let us check the marking scheme also. He says it is less dense than the cooler water. 1 mark for saying this. And it floats on the cooler water. Cooler water cannot move on. Cooler water remains on the bottom. He has used the reasoning of that density thing. Will you like to write the answer? The marking scheme is showing on your screen. It's a 2-mark question. Please write your answer and then we will check if your answer is good or no. Shabash, shabash.
कुसुम
Yes.
इसका यार ये it is less than the cooler water.
इसका उन्हें hot water and the cold water have different densities. Hot water have less density, so it is above cold water. Heat is transferred through
Hot
convection
water.
current.
Cold water has higher density and the hot water has less density. So that's why the cold water cannot go up.
Sir, मैंने लिखा है hot water
Yeah.
and cold water have different densities. Hot water have less density, so it is above cold water. Heat is transferred through convection currents in liquid. Cold water cannot go up as have high density. Sir,
Okay. You see, in the marking scheme, he used only the analogy, you said the reasoning of the density. He did not went into the convection currents. Let me
okay,
read
sir.
the question. So let's see why he's not using that thing. The reservoir, so you only have to, it does not mix with the cold
Heat
water in
नहीं
the,
provide इसीलिए.
okay. Why those waters are not mixing
Sir,
with
बात
each other? The
कर
reason is the difference of the density. The less dense material is above and the more dense material is at the bottom. So they will not mix because the more dense material do not go above the less dense material. Anybody else will like to read the
Okay.
answer? The answer you have written, anybody will like to read?
Sir,
Hot
मैंने
water
read किया
has
है.
less density. Hot water has less density than the cold water, and the cold water can go above the hot water, so they will not mix.
So more dense material cannot go above the less dense material. Okay.
Yes, sir.
Should we move to the next question?
Yes, sir.
Okay. So it says when the tap is opened, water at the room temperature from the reservoir flows down into the tank. Cold water from the tank flows through the plastic pipe and out of the tap. Cold liquid from the refrigeration unit is pumped through the copper pipe and thermal energy passed through the copper to this liquid. Suggest why this pipe is made from copper. Why it is made of copper? Hello?
पता नहीं सर.
Yes, sir.
This pipe, this pipe is made of copper. The reason is, try to understand this reason. Okay, don't write the answer, just try to understand. You know, this is the refrigeration unit. This is the refrigeration unit. It has a gas in it. You must have heard, okay, gas leak ho gayi hai, gas here. Huh? That cold gas comes in this pipe and then goes back, get a cold and comes. So in these pipes, these copper wires, in these copper pipes, we have that chlorofluorocarbon. You must have heard this word. The gas which is in the AC, the gas which is in the refrigerator. Have you heard the gas in the refrigerator or AC?
Yes sir.
Okay.
Yes sir.
So that gas is cooled by the compressor and it is inside the pipe, these copper pipes. That is very cold. It is fed into these pipes and then it goes back to the compressor. The water here is hot.
Sir, नहीं समझ.
The
तो गैस
water
की
here is hot.
कॉपर पाइप के अंदर.
The gas is inside the copper pipes. The water is outside the copper pipes. The water is has surrounded these copper pipes. The water is hot. So the heat will be conducted by the copper pipe. The heat from the hot water will be conducted. The heat will go
Sir, समझ.
inside the pipe. So that gas will become hot and go back to the compressor. So why this is made of copper? So the heat from the hot water can be conducted to the gas which is inside the plastic pipes. Do you understand this idea? Then we can look at the marking scheme also.
Yes.
Yeah.
Yes,
Yes
sir,
sir.
आ गई है.
Okay, let me check the marking scheme also. It's a 1 mark question. The reason is the copper metal is a good thermal conductor. That's it.
सर जो आपने बताया वो नहीं लिखा.
नहीं, वो तो अंडरस्टैंडिंग के लिए है ना, मैंने कहा आंसर नहीं लिखना.
Okay, sir.
It's a 1 mark question. I was explaining you the concept that how this thing is done. Yeah,
Done sir.
done. It's a 1 mark question. Very
Yes.
simple answer. Okay. The next part is explain in terms of free electrons how thermal energy is transferred through the copper. It's a 3 mark question. 3 mark question. How
Conduct.
the thermal energy is transferred through the copper. You see, try to understand.
एक तो
You don't have to write here the vibration thing. Okay? The vibration of the atom. He is particularly asking how the energy is transferred, how the energy is conducted by the free electrons. You see, copper is a metal and it has free electrons. The free electrons on the hotter side of the copper, they will absorb thermal energy and their kinetic energy will increase and they will flow to the colder end of the copper, and there they will collide with the atoms of the copper and they will make them vibrate vigorously. So in this way, the heat is transferred from the hot end of the copper to the cold end of the copper by the free electrons. This process is also called free electron diffusion. Kursam, will you repeat this thing which I just told?
यस सर। सर
Yeah,
फ्री मूविंग आयंस जो होंगे ना वो
ions
वो
नहीं,
जब
electrons.
हाँ इलेक्ट्रॉन्स वो जब हीट गेन करेंगे तो उनमें वो काइनेटिक एनर्जी गेन करेंगे जिसकी वजह से वो फास्टर मूव करेंगे और फिर वो कोल्डर मतलब उन फ्री मूविंग इलेक्ट्रॉन्स के साथ कोलाइड करेंगे जिनकी लो काइनेटिक एनर्जी है तो फिर ऐसे ट्रांसफर हो जाएगी।
जो हॉट एंड है, एक चीज अब आप तुमने बताते हुए मिस की, जो फ्री इलेक्ट्रॉन्स एट द हॉट एंड है, they will absorb the thermal energy and they will go to that the other end and colder end. They will go to the colder end, and at there they will collide with the atoms of the copper and make them vibrate vigorously, and thus the temperature is transferred from the hot end of the copper to the cold end of the copper. Will you be able to write the answer? It's a 3 mark question.
सर ये जो फ्री मूविंग इलेक्ट्रॉन्स है हॉट एंड वाले ये ट्रांसफर हीट एनर्जी ये कोलाइड करेंगे एटम्स के साथ कोल्ड एंड वाले।
Yes, yes. This is what I'm
ओके
saying. See, there are 3 marks for this part. Okay. 1 point is for saying that vibrating atoms, ions, particles, molecules, electrons gain energy. The 1 mark is saying that atoms, ion, particles, molecules hit the electrons or electron travels a long distance through the copper. And the 3rd mark is for saying that electron heat transfer energy to the distant atoms, particles or molecules. Yes. Will you be able to write the answer?
Yes, sir.
Okay, please write.
लिख लिया सर।
Read your answer.
Uh, free electrons will gain kinetic energy, and the free electrons on the hot end will absorb the thermal energy and go to the cooler end.
Okay.
And this process is called free electron diffusion.
Okay. That's it.
Yes, sir. Okay,
Okay.
point.
So when they go to the colder end, there they collide with the atoms and of the copper there, and they make them vibrate vigorously. This is 1 point which is left.
सर मैंने लिखा है फ्री इलेक्ट्रॉन्स एट हॉट
Slowly,
एंड विल
slowly. Read
एब्जॉर्ब
your answer
काइनेटिक।
slowly, step by step.
ओके free electrons at hotter end will absorb kinetic energy will move vigorously electrons will travel a long distance and then it will collide with the atoms of copper on colder region and hence thermal energy is transferred through the copper।
Hmm.
good
The
answer।
free electrons which are at the hotter end will absorb thermal energy. Their kinetic energy will increase and they will move towards the colder end of the copper. There, these free electrons will collide with the atoms of copper and other free electrons there, and they will make them move or vibrate vigorously. In this way, the energy is transferred by the free electrons. In this way, the energy is transferred by conduction by the free electrons in the copper. Do you understand? This is
Yes.
called free electron diffusion.
Yes, sir.
Okay. Should we move to the next
Next
slide?
part. Yes, sir. So lesson over हो गया है.
Eh? At what time this
11.
lesson will over?
11.
Let me check the timetable first. I have
Okay.
the time. Let me see. Let me show you. I have that time thing. So the second lesson will over at 11:15. So it's almost about to finish. Okay. Pursam, can you see that?
Yes.
Okay, sir.
Okay. Let's see how many questions are left. Oh my God.
एक क्वेश्चन और आता.
Acha. As the water near the copper pipe cools, it begins to mix with the rest of the water in the tank. As the water near the copper pipe cools, it begins to mix with the rest of the water in the tank. Explain how this happens. The water which is near the copper wire becomes cold and it becomes dense. So it moves downward because it has become dense. So it can mix with the other cold water. Do you understand what I'm saying?
No.
You see, here we have cold water. Here we have cold water. Here we have cold water. Here we have hot water. The water which is here near the copper pipes, because its heat is gone inside the pipe. So this water here will become cold. When it will become cold, it will become dense. When it will become dense, it will move downward. So it will mix with the cold water because it has also become dense. Now do you understand?
Okay.
Do you understand?
Yes, sir. ये hot water की heat गई है.
जो the water is hot here above here. The water is hot.
और वो above की heat गई है इस copper pipe के
Copper
through.
pipe, yes. Copper pipe is absorbing the heat from the hot water. ये cooling कर रहा है ना? It's doing the cooling. Let me show you the marking scheme. This is the marking scheme. Three marks. Okay, on your screen. One mark is for saying that it contracts or its density increases. One mark is for saying that it will sink, and one mark is for saying that the less dense and warmer water rises or sets up the convection current. Now he's using the word convection currents. Mira Babidla. Mira was also. You have to explain what happens.
ओके सर, आ गई है समझ.
So what you have written?
Hot water heat is transferred through copper pipe through conduction. Hot water Hot water heat is transferred through copper pipe through conduction. Hot water density increases, water sinks downwards, and convectional current is set up.
Okay.
Next part.
So now you are on me only. Okay.
Yes.
Okay. He says the tap is opened and water is 21 degrees centigrade flows from the reservoir into the tank. The specific capacity of the water is 4200 joules per kg per degree centigrade. Calculate the thermal energy that is removed from 250 gram of water to reduce its temperature to 7 degrees centigrade. Use the formula. Let me show you. Heat is equals to mc delta theta. Heat is equals to mc. Heat is equals to mc delta theta equals to mc delta theta. Okay. The mass is 250 gram, but this should be in kg. How do I know that it should be in kg? Because the unit in the specific heat capacity for the mass is kg. So I will write 250 divided by 1000. It will be 0.25, and then we multiply it with you multiply it with
4200.
yeah you multiply it with the specific is 4200, and you then multiply it with the change in the temperature. From 21 the temperature dropped to 7, so the change in temperature is 14. So just multiply and get the answer. Kosam, have you got it?
1470. 14700.
Yes, that's the right answer. 14,700 joules is approximately 15,000 joules. So that's good.
Next part.
Yeah, next part.
Describe the motion of the molecules in a liquid which is at uniform temperature throughout.
Describe the motion of molecule in a liquid which is at a uniform temperature throughout. The liquid molecule will be moving randomly. You see, it's a liquid. It's a molecule of a liquid. It will be moving randomly because the temperature is uniform. So its kinetic energy will not change. Its speed will not change, but it will be moving in randomly. Okay, it's a 2-mark question. Let us check the marking scheme also. He says any two from one is that the molecules they move in clusters, and the one is slide over each other molecules they move throughout the liquid. Okay, he's using these properties. One is that they move in cluster, they move randomly, and they move in clusters. And the other is they move throughout the liquid, or you can say they slide over each other. Kusam, write the answer.
क्लस्टर का क्या मतलब है?
वो 3 4 5 6 इकट्ठे होके मूव हो रहे हैं.
ओके सर,
Not a
नेक्स्ट करते हैं.
single molecule.
मैंने लिखा है liquid will be moving randomly throughout the liquid. Its kinetic energy remains same. They move in clusters.
They move throughout the liquid, they move randomly, they move past each other, they move in clusters. And you say liquid moves. Say molecules of the liquid.
Okay.
The opening sentence you wrote that the liquid moves in this manner. Just say molecules of liquid move like this manner.
Okay.
Okay.
State
So the
what
last
happens.
part.
State what happens to the motion of the molecules in a liquid as the temperature of liquid decreases.
They
Kinetic
will
energy
start.
decreases.
Temperature decreases, so their speed will slow down, their kinetic energy will slow down, and the distance between the molecules will also decrease.
मोशन का सर पूछ
Only motion is asked. Okay. So the average speed or the I'm looking at the marking scheme. You can also see that average speed or the kinetic energy decreases.
ओके
You understand?
यस डन
Okay. So this is enough for today.
ओके
So what you will do? You will take the whatever you have written. Hmm?
यस
Take its photos and upload and send the photos to me. Okay. But the
ओके
photos
सर
should be not the whole. The photos should be of each answer. Okay. Very clear photos.
अकेली अकेली एक क्वेश्चन की
अकेली
या
से
पूरे पेज की
अगर पूरे पेज की लो, the photo should be taken very sensibly and it should be very clear.
और व्हाट्सएप पे भेजनी है ये
और मुझे
क्लासरूम
भेज देना, मुझे भेजना.
ओके सर
Okay.
बाय
Okay, beta. Thank you very much. Have a good day. God bless you. Bye bye.